following is a presentation of Aviation Maintenance Publishers' Video Graphics Division. Aviation Maintenance Publishers is dedicated to professionalism in the education and training of aviation technicians. To help meet the increasing demand for skilled personnel in the aviation industry, we have produced this series of videotaped programs on the practical applications of your technical training. These programs are designed to complement the personal instruction you are receiving. The information contained in this series is intended as a guideline and should be used in conjunction with the appropriate Federal Aviation Administration documents and manufacturer's publications.
Of all the many systems in the modern aircraft, the one system that probably suffers the most abuse is the landing gear. Not only must the landing gear support the full weight of the aircraft while it's on the ground, it must also absorb the tremendous punishment from the force of landings, which are not always smooth and gentle. Since there are many different types of shock struts in use today, only information of a general nature will be presented here. For specific information about a particular aircraft, always consult the manufacturer's service information. Oleo struts are self-contained hydraulic units, which must be inspected and serviced regularly. Aircraft Oleo shock struts are very similar in function to the shock absorbers on an automobile. If a car's shock absorbers are worn or damaged, the car will wallow, dip, or lean. This could cause a loss of control and, in turn, cause a serious accident. On an aircraft, damaged or poorly maintained shock struts can cause directional control problems while taxiing or during the critical moments of takeoff or landing. They may also prevent proper retraction or extension of the landing gear. In this presentation, we'll be discussing the construction, operation, and servicing of the typical aircraft Oleo shock strut. A typical pneumatic hydraulic shock strut uses compressed air combined with hydraulic fluid to absorb and dissipate shock loads, and is commonly called the air oil or Oleo strut. The Oleo strut is made up of two tubes which telescope one inside the other. The tubes are closed on the outer ends. The outer tube is referred to as the cylinder, and the inner tube is called the piston. The cylinder and the piston, when assembled, form an upper and lower chamber for the movement of fluid. The lower chamber is always filled with hydraulic fluid, while the upper chamber contains compressed air or an inert gas, usually nitrogen. A packing gland designed to seal the sliding joint between the cylinder and the piston is installed, and a packing gland wiper ring is installed in the lower bearing gland nut to keep the sliding surface of the piston free from dirt, ice, mud, and snow. Foreign material entering the packing gland could result in leaks. An orifice is placed between the two chambers to provide a passage for fluid into the upper chamber during compression and a return path during extension of the strut. Most Oleo struts employ a metering pin which controls the rate of fluid flow from the lower chamber to the upper chamber during compression. On some types of struts, a metering tube replaces the metering pin. However, the operation of the strut is the same. Many Oleo struts employ a damping or snubbing device to prevent damage to the landing gear caused by too rapid extension of the strut. Such action could cause a sharp impact at the end of the strut travel. A fitting consisting of a fluid filler inlet and an air valve assembly is located near the upper end of the strut and provides a means of filling the strut with hydraulic fluid and inflating it with air or nitrogen. Oleo struts are equipped with either an axle or axle attachment at the lower end of the strut. Connections are also made at the upper end of the strut for attachment of the strut to the aircraft. Torque arms are attached to the cylinder and the piston to maintain the proper alignment. Let's take a look at what happens during the landing. The metering pin is forced through the orifice as the piston moves upwards. At the same time, fluid is also forced through the orifice. Since the metering pin is tapered, the size of the orifice is continually decreasing as the pin moves into the orifice. As the fluid is forced into the upper chamber, the air is compressed in the top of the chamber. As the strut nears the end of the stroke, the air is further compressed. It is the air that carries the weight of the aircraft on the ground. An insufficient amount of either fluid or air in the strut would permit the strut to compress completely or bottom. This could cause damage to the landing gear or the aircraft structure. Shock strut servicing is one of many simple operations performed by aircraft maintenance technicians many times during their careers. As with any job, the first task is to select the proper tools and service information. Servicing should be accomplished on level ground, ideally in the hangar. Open the necessary inspection plates or remove the cowling as required to gain access to the air valve located on the top of the strut. Two of the various types of high-pressure air valves used on shock struts are the standard and the winterized types. The standard air valve contains a valve core and has a 5/8-inch swivel hex nut. The winterized air valve has no valve core and has a 3/4-inch swivel hex nut. Remove the protective cap from the air valve, exposing the valve. If the air valve is equipped with a valve core, release any air pressure that may be trapped between the valve core and the valve seat by depressing the valve core. Under no circumstances should you depress the valve core with your finger or fingernail. When performing this task, always wear protective goggles and keep your face to one side of the air valve, since high-pressure air can cause serious injury. Wait until the fizzing of the air and fluid stops and the strut is completely collapsed. In addition, anticipate the rapid dropping of the aircraft when the air is released. Remove the valve core. In some cases, it may be necessary to rock the aircraft after the valve core is removed to be certain that the strut is completely compressed. Visually check the strut to make certain that it's fully collapsed. Remove the filler plug and check the fluid level. If it's necessary to add fluid, be sure that you use the approved type as recommended by the aircraft manufacturer. If fluid must be added, fill the strut through the filler plug. Fill the strut to the level of the filler plug opening. Install the filler plug, making sure that the seat is clean and free of burrs. Install the filler plug finger tight, being careful not to cross-thread it. Torque the filler plug to the value recommended by the aircraft manufacturer. Install the air valve core. We are now ready to inflate the strut. Inflation must be accomplished using nitrogen or a dry air source. Nitrogen bottles are used because they provide a convenient source of a dry, high-pressure, inert gas. On some shock struts, the correct amount of inflation is determined by using a high-pressure air gauge, while others require that the extension between 2 points on the strut be carefully measured. The proper procedure for measuring inflation can usually be found on an instruction placard affixed to the strut, as well as in the service information. Connect the nitrogen supply to the strut filler valve and carefully begin the inflation procedure. While inflating the strut, rock the aircraft gently to overcome packing friction and to avoid possible overinflation. When the correct amount of extension has been achieved, turn off the flow of nitrogen and disconnect the hose. Test the valve core for a tight seal by using a small amount of soapy water. If there is any leakage, bubbles will form at the point of leakage. If leakage is discovered, it may require that the strut be deflated and the leak repaired. The usual causes for leaks are a bad valve core, loose air valves, or failure to replace the O-ring before replacing the air valve. Replace the valve cap and secure it finger tight. Red indicator tape is sometimes installed at the base of the strut piston. On a routine inspection of the landing gear, any bottoming of the strut will be revealed by distortion of the tape. Correct servicing of the landing gear Oleo struts is vital to the safety and dependability of the aircraft. Through proper service of this vital link, the technician can be assured of smooth and safe ground handling and trouble-free takeoffs and landings.